Hey, hello and welcome back. This is tutorial number 14 of my Ultimate Ladybug course. I'm Philip and in this video we will unlock the secrets of the psychrometric chart. Now, in the previous two videos we looked at the hourly plot in Ladybug and the monthly chart in Ladybug. Both charts are very general. You can basically just put any dataset, any hourly dataset, as long as it fits the format. You could put it in there and you will get an output. For example, the monthly chart is a very simple diagram which you could recreate in Excel if you want. Now, the psychrometric chart is a very specific chart. I think it was developed in the 70s. I'm not sure. Google it if you want. It's around quite a long time, but it tries to illustrate the human comfort. It's another way to illustrate human thermal comfort in an environment, either indoor or outdoor. And it takes into account the temperature, it takes into account the humidity, the air movement, and a few other components which are optional, but they make it more accurate. Before I tell you too much, let's jump into Rhino and let's have a look. For everyone who hasn't watched my videos, please go into the show notes. I will post the link for the entire playlist so you can watch the videos. I recommend if you never used Ladybug, that is where you start. If you never used Grasshopper before, I would recommend to do like a crash course in a Grasshopper first before you do any Ladybug stuff. But yeah, it's up to you. Now, this is what we're trying to recreate in this video, and you can see for the people who already saw some of my videos, you know that there was way more stuff in here, and it's just all the things we built in the previous videos. I just copied it and placed it in a new file. I will clean this up at some point and use it as ready-made components for other videos. This actually would be quite a good. It's a time saver really, just to have these ready-made blocks of code or blocks of script to just grab and get and use it in your new script. The way how it works, you just get something, Control copy, Control C, and then you can paste it here, and then you have this component. Pretty straightforward. In order to follow this video, you only need a weather data really. What we did in our project in Kikomero, we modified our weather data. That's why we have a bit more script here. We modified our weather data because of the distance. We tried to make it more plausible, and we used a dragonfly component for this. But the output is also just the weather data. So you can also just use a normal weather data to follow along. If you don't know how to import weather data into Ladybug, please go back into the first script of this series. In the first video of the series. Then there you will see. There you can learn about how to import weather data. Now, this is the output of the weather data. I will delete all this because this is my chart. Just get rid of this. I only have here a point in Rhino, which we will use later. And I have my model. We'll get there very soon. Now, looking at Ladybug. Where is it? Ladybug? No, Ladybug here. We're using Ladybug 1.6. I'm not sure if there's a new version, but I think it's still valid. Normally things don't change so much. Sadly, because sometimes there are bugs or wrong descriptions which are not getting resolved for a long time and over several versions of the software. Anyway, we'll get there and we'll see one today. It's not really a bug, it's more a description. So we looked at the hourly plot, the monthly chart, sorry. And now we're getting very close here. This is going to be so interesting. Sky metrics and cumulative sky metrics and Ladybug sky dome and so on. This is going to be super, super interesting. Well, we actually go through, we'll look at our model. We're still here. Let's finish these off and then we can get into the interesting part. So we have here the Ladybug psychrometric chart. The PMV. What's the PMV? The PMV, as you can remember, we had this tool here. It's called Ladybug PMV Comfort. And we can put this in here just to read what PMV means. And it says predicted mean vote. The thing here is that this tool only works with this. So we need this one in order to run this one. And I said before that there's something wrong with the description. Here it says psychrometric chart, and then when you open it, it says an hourly, daily, or sub-hourly data collection of temperature values or single temperature value in Celsius to be used for the whole analysis. That's actually wrong. You need to import the psychrometric chart here. That's what you need to do. And we will see what it does. We will see what it actually does. So I disconnect this for now. If I would be the developers, I would put the psychrometric chart first and then the PNV polygon, because actually it just marks an area on your psychrometric chart. All right, so this one, it's very straightforward. We can put here the temperature. When we talk about temperature, it's normally, when you say temperature, normally what it's meant is the dry pulp temperature. Then we need to have the relative humidity, the air pressure, barometric pressure. We can have a base point. We don't have to have a base point. And we also need to be careful that pressure, I don't think we fixed the pressure in our scripts, did we? Yes, we actually did. Because we are higher up, so the pressure changes. We just tried to made our weather data fit to the space better. It's not perfect, but it's better than nothing. And then here's this base point. Base point means the location in Rhino, in your Rhino scene. At the moment, it just places it at 0, 0, 0, which is somewhere here. And we can change that by just adding a point container. And somebody just asked me last time, how can you bring geometry into Grasshopper? Well, geometry into Grasshopper is just linking it with Rhino. So if I have a point here, you press on the middle and say set one point, or geometry, or whatever you're referring to, and place that here. Now our chart is here, and it actually already created everything. This is so fast. Super fast. We could stop the video here. What else could we change here is we could change the scale. And this is also interesting. Scale 1 means what we had is the default, but we can also, of course, have larger depending on how big you need it. You can change however you want this. Temperature range, you could put a temperature range and there's already a default in here, and if you can see the default, or you could put basically your range in here, or you just create one. And to create the range, you can just say, let's say 20 to 50. Let's see if that works. Yeah, that works. So now my range is from 20 to 50. There is a specific range object. You can also set, it's actually a domain. So you could set a domain, construct a domain. That's another way to do this. So you could have here 20, and here you're gonna have 50 or whatever, 50, or this is, let's say it's 5 to 60. That's another way to do it. Let's keep this. It's more convenient because we can shift this around. And we started, it's 0, and we could say, okay, it never has 50 degrees here. So let's say 35. Now this is my psychrometric chart. It gives here the name of the city, the country we haven't specified in the weather data, because it gets all the information from the weather data. Time zone, and source is none, because the source is actually myself, because I modified the weather data here. And then what we actually see here, we see the dry pulp temperature, and then we see the humidity ratio, which is how much kilogram of water is within 1 kilogram of air, to kind of specify the humidity. And then on this side, on the curve, we can see the enthalpy. It's the potential energy which is within that air. So it doesn't tell us much. I mean, it just tells us the extent of this. It only tells us the extent of the humidity ratio and the extent of the temperature. It goes from roughly, let's say 7 degree to just below 30 degrees, 28. Well, it's the extent over the whole year at the moment. Because we can, and then most importantly, the legend. The legend shows how many hours in the year is a certain situation. You have a certain situation. So the lowest, this dark blue, is just 1 hour per year, and red is actually quite a lot. Is 500 hours per year, more than 500 hours per year. And we could now go here and check what else can we put in here. This is all now optional input. Plot wet pulp temperature, wet pulp. Boolean to note whether the psychrometric chart should be plotted with lines of constant enthalpy or lines of constant wet pulp temperature. Okay, we can just place here true or false. It's actually a Boolean toggle. That's the current default. If we change that, let's see what happens. I see. So now it changed these lines relating to the enthalpy. Oh no, actually, sorry. So if we go back here, it just shows the temperature, and with false, it shows the enthalpy here. Legend parameters, we talked about legend parameters before. You can find them here in the extras. Legend parameters, we could choose a different color for these. We could also set a minimum and maximum. I think we don't need that really here, but other things, of course, there could be interesting, especially if you want to have a more straightforward legend. Then you could set the segments, how many segments, and then a maximum. You could say minimum and maximum. Maximum you could, for example, have 600 instead of 500. So you get a bit more a cleaner output. But we discussed it already last time. What's also important here, again, we have the visual set output. We could output this in a more cleaned up version. Where is it? It's this one, the visual set, preview visual set. Oh, we discussed this, so it made some nicer line. It changed a bit of the line thickness, and it can also have like 2D legend parameters here. Optional data collections. I never tried this. I never needed it. This is if you really more advanced users. Statements. We talked about statements before. You can say here A is larger than 10 or larger than 15. Then everything below 15 is not shown. There are more examples for statements. You just read through and you see what you can do. And then we can have a period. We can also measure a period. In my case, because it's rainforesty kind of environment, it doesn't really change. Well, there's a rain season, and we could check that. Actually, it's interesting. Let's do this. So I could get my weather period from here, which we did already. But because this is a tutorial, let's just rebuild it. Periods. Analyze period. Yes, here. 12. Oops. 1 to 12. Okay. We can use the same here. We can use... and if we have this month, you could already, for example, just check months. Here, let's say we check from March, or maybe, March. No, April. From April to August. Maybe March to June, April, July. So April to end of June. So that's what we're checking. Because here are already default values. So start day is 1, start hour is 0, end hour is 23, end day is the 23rd. Oh, I think there's nothing in here. Let's see. Let's check the period. We can always see what the output is. Oh yeah, it works. So here we can see the period. It's from the 1st of March to the 30th of June, between 0 and 23. And 23 is always the hour from 11 p.m. to 12 o'clock. So that works, and we can use this here. Now it changed a bit. If we turn this off, just to see a difference, then we have, so then you see how the output changes. If we add, it's just checking the 1 month, May, or October to December, or again the whole year. So that should actually show the whole year. If I remove this, so that's how the period works. And the output, here's nothing. Title, you can get a title. This is the same what you're gonna see here. Drive up temperature, humidity ratio, and time is hour, city is Gicomero, and so on. Temperature lines. This is just the output, the actual output of the geometry of that chart. All the different lines. The mesh which is this one. These are colored meshes. The legend, points, and the data. There's no data. And then we have the psychrometric chart output. That's where this second tool comes in. The second tool will actually tell you something about this chart, because now we see a range where it is most often. It's most often, let's say 18 degrees with about a 0.012 kilograms per air. That's what we understand. That's all we can see here. But it doesn't tell us much. So that's where this comes into play. We can place this here, and it already gives us an area. It marks an area in here. And let's see what it says here. Draw thermal comfort polygons on a psychrometric chart using the PMV model for indoor thermal comfort. So this is all about indoor, and it will tell us that within this range here, this area, this is our comfort zone. This is when it's most comfortable. Now, as you remember, we had the mean radiant temperature. That is the temperature, and these are all optional inputs. The mean radiant temperature is the temperature indoor. Now, we don't have indoor temperature, but let's just use what we have here. We have a temperature. Let's see, our indoor has no air condition. It has no heating, nothing. It's just a shelter. Then we can put this in here. Oh, no, sorry. Mean radiant temperature. We actually need to open a new tool if we want to fill all this stuff. We don't have to. It gives us some idea already. So this polygon already tells us, okay, within that range here, it's okay. The other time of the year, it's not. Which is actually most of the time. It's not comfortable. We could then of course check, okay, is there any month where it's better? No, we could check here. Okay, when is this the widest? Not really, but actually here we have more hours within that zone, within that area. So summertime still better than winter, feels like. All right, so let's get the mean radiant temperature. Mean radiant temperature, we can find this here. Ladybug indoor solar mean radiant temperature. For that we need, again, a lot of stuff. We looked at this already before, but now it's just coming back. And it's good because we can revisit what we already looking at, what we looked at before. So we can use it, what we already learned. The mean radiant temperature goes in here. Long wave mean radiant temperature. Well, now, long wave mean radiant temperature, always read what's written in here. A single number or an hourly data collection with the long wave mean radiant temperature around the person in degrees Celsius. This includes the temperature of the ground and any other surface between the person and their view to the sky. Typically, indoor temperature is used when such surface temperatures are unknown. Indoor air temperature. Well, we don't have the temperature, but we can use the normal dry bulb temperature. Direct normal radiation, diffuse horizontal radiation. Then we have the fraction body exposure. A single number between 0 and 1. It's about the human to sky relationship. We could say it's 0 if we're inside. Default is 1. That would mean everything's glass. But let's say we don't have that, so we could use here a panel and say 0. Interestingly, there's another thing which is called sky exposure 0.2, 0.1 if you're standing next to the window. I think this is about sun exposure and sky exposure. There's a difference. Then ground reference, you can have like a specific ground type. 0.25 is here the default, which would be like a characteristic concrete floor. Window transparencies, you could specify window transparencies. And then the solar body parameters, that is about how do you actually sit next to, well, there's more optional solar body parameters from the Ladybug solar body parameters, which you can find here. Opala, this is not what I'm looking for. Solar body parameters, which tells, we talked about this before. We talked about absorptivity, emissivity, how the person faces the sun, the posture, if it's sitting, standing, and so on. It becomes quite esoteric, but yeah, you can explore all these. Please do. And we have also here a run button. So we need to actually run this whole thing. Just copy here the Boolean toggle, and now it has run. And now I'm getting an error. Let's see if I can fix this. Okay, computer just crashed. or no, computer didn't crash, but Grasshopper did. I think it's not 100% figured out here. The mean radiant temperature, I can't really put in here, becomes red. It seems like it only allows one fixed temperature. I could put here 21.5, for example, but that's not very satisfying. I mean, if we have an input for mean radiant temperature and I expect that I can put mean radiant temperature, feels like it was never fixed, was not fixed really here. What I can do instead, if I really want to explore this more, I can put here, I can deconstruct everything. Then I only have values, no header values. That works, but don't put this in here. It just crashed my Grasshopper. So what we need to do is like average this. Otherwise it tries to, yeah, it seems like there's a bug really. So now we have an average temperature of 17.3 that I can place in here. The problem with this is that if you use a period, then you obviously want to have the average of that period and not of the whole year. But yeah, let's see what else. Let's look at the whole year. Something feels wrong. Airspeed. Here the airspeed also doesn't work with the wind speed. That doesn't work. It's just a very small number as a default. Let's put this in here. The met rate. A number or list of numbers for the metabolic rate in met. If none, a met of 1.1 met will be used for all polygons indicating a human subject who is seated. Again, so that means here we're already putting stuff if a person is seated, but this is about the metabolic rate. So it means about when you're using more energy, if you're running around, then of course you will your body's heating up, so it's better, it's cooler. If you're just sitting around and it's very cold, then it feels even more colder. That's about the met rate. There is a tool here, it's called the Ladybug Activities Met List, that you could use to put in here. So if you want to test different scenarios, sitting, cooking, house cleaning, strolling, walking, dancing, let's say dancing, and let's put this in here. Then, wow, that changed quite a lot. Completely on the different side of things. Lifting, okay. Running, oh, it's completely out here somewhere. Cooking, that's so if you cook the whole day then it's fine. Standing, sleeping, okay, that's quite outside the comfort zone. Typing, standing, driving, okay. Cooking is very popular. That's why cooking is so nice. It always feels comfortable. Nevertheless, so I mean, again, it's quite esoteric because, for that person it's too hot, for the others it's too cold. It's just really trying to understand a bit more. I mean, in the ways it's probably correct because, when I cook, I'm never too cold, really. Then you can specify the clothing here again. There's another tool here. It's called, what is it? This clothing list. Yeah. So let's, can put this in here. It doesn't add the elements together. So we need to do a mass addition, and then the output is here. So if I wear underwear, socks, shoes, long sleeve, dress or trousers, dress shirt, sorry, and then trousers and a coat. Let's get rid of the coat. Then it's fine. Then I can cook and I'm perfectly comfortable the whole year, almost the whole year. It's quite funny. You can merge all the polygons in here to a single mesh. You can add optional text input for passive strategies. Never done this before. This is for advanced users. Strategy parameters. Okay, there is another tool here. It's called the passive strategy parameters, where you can add additional information. The airspeed of the fan. Okay, so if we go through here, day above comfort, a number in degrees Celsius representing the maximum daily temperature above the comfort range which can still be counted in the mass and night vent polygon. I don't know. Yeah, I mean, again, we can make it, it could go from 0 to, infinite. You have infinite options here. Solar heat cap, fan, airspeed, balance temperature. Solar heat cap, what's that? A number representing the amount of outdoor solar flux that is needed to raise the temperature of the theoretical building by 1 degree Celsius. The lower this number, the more efficiently the space is able to absorb passive solar heat. I mean, it goes quite into very, very detailed stuff. And there's a huge description which we can look, or you can look when you want, if you want to learn more about that, if this is interesting to you. At the moment, to be fair, it's gonna be a very simple architecture, and there won't be much heating and cooling happening. But then at the same time, the passive solar heating could be very interesting. So I think you get an idea on what you can measure now, because this is for indoor. This whole PMV test or check is for indoor air comfort. We haven't built anything yet. I just want to show you what's possible and what is available. And then later on, you will remember and say, yes. And you already you created a simple model for your building. Then you can start to think, okay, what material should I use for the building? Which materials are available in that region anyway? And it's a way to start, right? So from here, you can go in so many different directions, you can explore so many different avenues, which would not fit in one video. Now we know about this chart. We know that it exists, and it's quite interesting. So, use it, and the more you use it, the more you will understand it, and the more you will be able to use it in your project. In the next video, we will look at the sky metrics and what we actually need to do with it. What can we do with the sky metrics? All right, I hope you liked this video. It's getting really interesting. I think one more video, we'll look at sky metrics, and then we will start to look at our model and we start to design things. So there will be this series might split into 2 avenues. One is the actual design and one is Ladybug, but I will try to keep everything in one place and do the whole project within and with Ladybug. So let's see how that works out. See you in the next video. Ciao.